Good morning, folks. Today we're going to be talking about absolute value functions and their graphs. Let's go ahead and get started. We're going to start by looking at a linear parent function. It's the equation f of x is equal to x, or if you will, y equals x. If I want to graph a function, all I do is need to find the x's and the y's. Well, if I substitute in an x of 0, a y of 0 comes out. A 2, and then a 2 comes out, because this is a function of y equals x. The x's and the y's have to equal each other. In an f of x of equal absolute value of x function, it starts out the same way, because the absolute value of positive numbers and 0 are the same number. However, when I get to -1, the absolute value of -1 is positive 1, and the absolute value of -2 is positive 2. So these negative numbers aren't going to be here. The absolute value graph is going to go back up again. So here's what you need to remember. An absolute value graph is going to have a V shape. It's going to be symmetrical around the y-axis. Its vertex is going to be the minimum point or the maximum point if it's been reflected. Keep in mind also that if it's got intercepts, x-intercepts, those are zeros, or a y-intercept is where it crosses the y-axis. So, a vocabulary for a f of x equals absolute value of x. This is an absolute value parent function. The highest or the lowest point of the graph is going to be called the vertex. And then the zeros of a function are the x-intercepts. Those are going to be located at the x-axis. These are the inputs where the outputs or the y's equal 0. And then, of course, the axis of symmetry is a vertical line that divides the graph into mirror images. And that axis of symmetry is going to always go through the vertex. And next we're going to talk about transformations of absolute value functions. Transformation, just to review, is when we change the graph size, shape, position, or orientation. Now, a translation is a transformation. However, it just is a horizontal or a vertical shift. It does not change the size. And then remember, when we multiply the entire function by -1, it reflects over the x-axis. All right, so the parent function of an absolute value function is y equals absolute value of x. Clearly, there's more complicated ones than that. And so here is a absolute value function in standard form. And all these letters tell us different things that have happened to the graph compared to what the parent function was. So let's start at the very beginning. If there's a negative sign in front of the function, that means the graph has been reflected over the x-axis. The next thing is if there's a number in front of the absolute value sign, if it's bigger than 1, then the graph got stretched. It's going to be skinnier. And if it's between 0 and 1, it's going to be fatter than the parent function would have been. And then the h, that's going to tell us whether the graph shifted from the left or the right. And then the last thing is the k, that's the number at the end. That's going to tell us whether the graph shifted up or down from our parent function, the v at the origin. So remember, hk is the vertex of our absolute value function. And also keep in mind that this a that's in front of the absolute value, it acts like the slope. Because remember, our function is really just two lines. They have the same slopes. So here's an example of a parent function. And you'll notice that if all I did was multiply the parent function by -1, it reflects over the x-axis. So that's what a reflection looks like. So let's see if we can't use this standard version of the absolute value function to tell what's going on with these different graphs. So for number 1, you notice it's got a 3 in the front. That means that the graph's been stretched by a factor of 3. It means that the slopes of the two lines are 3 and -3. You see how it's a +2? That means it went to the left by 2. And you see where it's a -3? That means it goes down by 3. So if I go to my vertex, which started off at the origin, and I go to the left 2 and down 3, I find out that the vertex is -2, -3. All right, let's try this next one. Then number 2, there is no number in front, so that means the slope of my two lines is going to be 1 and -1. It moved to the right by 1, and it went up by 2. So if I go right 1 and up by 2, then my vertex is going to be not at 0, 0 anymore, but it's going to be at 1, 2. And then the last one, it's got a negative sign, so that means it's been reflected over the x-axis. It's got a 1/3 in front of the absolute value sign, so that means it's been compressed by a factor of 1/3. It's going to be fatter, wider. And then it says -2 inside the absolute value, so that means it went to the right by 2. And then it says +1 at the end, so that means it went up by 1. So let's go back to the origin. And if I start at 0, 0, and I go right by 2 and up by 1, that gives me a vertex of 2, 1. Now what I want you to notice is that if you're looking at the function, you can see the vertex. Notice how it looks almost exactly the same. It's going to be the opposite of the number in front of or inside the absolute value, but this is a really easy way to see the vertex. You don't have to go through and sketch it out. Now, one of the cool things about transformations and functions is that the rules are the same for every function. So here we have the rules for a quadratic function. The rule is written in function notation, and basically we just read it the way it says. I'm taking away a number from the x's, and then that's going to shift it to the right. The second one says I'm going to add a number to just the x's. That's going to shift it to the left. This next one says that if I add a number to the end, it's going to shift the graph up. Here are the same rules for a radical function. If I'm going to add a number at the end, it's going to shift it up. If it's a negative number, it's going to shift it down. If I take away a number from the x's, it's going to shift it to the right. If I add a number to the x's, it's going to shift it to the left. If I multiply the whole function by some number, it's either going to stretch it or it's going to compress it, depending on what size the number is, bigger than 1 or between 0 and 1. And the other one we've talked about so far is that if I multiply the whole function by a negative number, it's going to reflect across the x-axis. You may recall this from last year. If you multiply just the x's by -1, it's going to reflect it across the y-axis. Well, quite frankly, we're not looking at a whole lot of that right now. So here are the rules for the absolute value functions. And you'll notice, again, it's written in function notation here. If I take a number and add it to the end, which is what they are doing, then it shifts it up. If I take a number and do it to the x's, well, if I added it, it's going to shift to the left. If I subtracted it, it's going to shift to the right. If I multiply the entire function, it's either going to stretch or compress it. And if I multiply the entire function by -1, it's going to reflect across the x-axis. So basically, if you just learn these rules, then it doesn't make a difference what kind of function you're looking at. Then you're going to know what's going to happen to the graph compared to the parent function. So what we're going to do is we're going to do a little practice. And like I said, this f of x function, I don't know what it is. It could be a square root function. It could be a quadratic function. It could be an absolute function. It doesn't make a difference what it is because the rules are going to be all the same. So in this question, number 1, tell me what happens to the graph of f of x if I add a number to the end. Yeah, the graph shifts up by 3. So tell me what happens to the graph of f of x if I take a number and add it to just the x's. Yeah, the graph is going to shift to the left by 2. So why don't you try number 3 and 4 on your own and pause the video and then start back up again and then we'll compare our answers. All right, awesome. Hopefully you did that. You'll notice that in this number 3, that what's happened is that we're taking a number and multiplying the entire function by it. The number is bigger than 1. So that means that we have stretched it by a factor of 3. And then hopefully you'll notice that we have multiplied the whole function by a negative number. That's going to cause it to reflect over the x-axis. And then the number itself is between 0 and 1. So then that's going to result in a compression. All right, awesome. In these, there's more than one thing happening. We'll take a look at the first one together. In the first one, you'll notice that we're taking away 2 from the x's. That's going to shift it to the right by 2. You'll also notice that we're taking away 5 at the end. That's going to make it go down. So what we're going to say to this function is that this function shifts to the right by 2 and then down by 5. So what I want you to do is I want you to take a look at number 6, 7, and 8. Pause the video, try these on your own, and then start back up again when you're ready, and we'll compare. Awesome, hopefully you did that. So let's see, in this number 6, you'll notice we multiplied the entire function by 3. That's going to cause it to stretch. And then at the end, we added 7. That's going to make it go up. So this is going to be a stretch by a factor of 3, and it's going to shift up by 7. So number 7, well, you'll notice that first there's a negative. That's going to cause it to reflect over the x-axis. Then you'll notice it's multiplied by a number that's smaller than 1 and bigger than 0. So that's going to make it compress. And then you'll notice the x's, we added 3. That's going to make it go to the left. So this one is going to be reflected over the x-axis, compressed by a factor of 0.3, and then it's going to go to the left by 3. And in the last one here, you'll notice this 2 in the front is a stretch because it's bigger than 1. You'll notice that we took the x's and added 3. That's going to make it go to the left by 3. And then at the end, you'll notice we took away 1. That's going to make it go down. So this is going to be a stretch by 2 and shift to the left by 3 and down by 1. All right, now what we know about transformations is going to help us when we try to do some graphing. So let's go ahead and take a look at that. So let's go and take a look at this one. In this case, they give us a function. They want to know what the vertex is. Well, it's going to be -3, +2. The slope of the lines are going to be 2 and -2. This negative sign in front means that the graph has been reflected over the x-axis. So let's go ahead and do that. We know the vertex is -3, +2. We know the slope of our two lines are 2 and -2. So let's go down 2 and over 1, down 2 and over 1, down 2 and over 1, down 2 and over 1. And then let's go and do the other way, down 2 and over 1. And so you see how we've created this V, and it's reflected, obviously, over the x-axis. And that is a graph of this function. And we did it pretty easy without a calculator even. Now the y-intercept is 0, -4, and the x-intercepts are -4, 0. And now in this next one, they've given us a function, an absolute value function. And let's see if we can compare it to the parent function y equals absolute value of x. Well, first you notice the negative sign, so that means it's been reflected over the x-axis. Then you notice the 1/2, so that means it's compressed, it's wider by one factor of 1/2. That also means the slope of the two lines are 1/2 and -1/2. You see that it's a -1 inside the absolute value, so that means it moved to the right by 1. And then you see it's -2 at the end, so that means it went down by 2. -2, 0. Okay, so let's start by doing a quick sketch of the parent function. We know the vertex of the parent function is going to be at the origin, and then it's going to go up 1 over 1, up 1 over 1. It's going to have a slope of 1 go on both sides. So now let's take a look here. Our vertex is going to be 1, -2. So let's go and plot that. We know it's reflected over the x-axis, and we know our slope is 1/2. So I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. Connect these with lines and put little arrows on the end. And I've got the graphs. So that's how these two compare. This is just pretty much the opposite. They give us the graph and they want us to come up with the function. So it's been reflected, so that means it's going to be a negative sign in front. I look at the slopes. You notice how it goes down 2 over 1, down 2 over 1. I know its absolute value. Look at the vertex. It's going to be x minus 3 and then plus 2 at the end. I can tell that just by looking at the graph. So why don't you try doing this one? So let's go ahead and try to do this one. First, remember, we're looking to see if it's reflected. No. You can take a look and find the slopes. It goes up 2 over 1, so that means the slope is 2. We look at the vertex, and we find out that it's -1, so that means inside is going to be +1. And then it's 3, so at the end it's going to be +3. So that's all there is to that. Okay, now the last thing I want to show you is actually graphing these absolute value functions in Desmos, because you're going to have access to that. So let's go ahead and take a look at this. You click the keyboard at the bottom, you see the absolute value down there above ABC. I'm just going to put a parent function in here first. So this is y equals absolute value of x. And you notice how it creates a v. Just what I expect. It goes up 1 over 1, up 1 over 1, 2 lines with slopes of 1 and -1 that meet at the vertex of 0, 0. Now what I'm going to do is I'm going to create a function, the standard function with the a and the h and the k that we talked about. And then I'm going to make them sliders. And so what we're going to do is we're going to see what happens when we slide these things around. So let's first get this back to normal. Everything's going to be, well, a is going to be 1, h is going to be 0, and k is going to be 0. Now that's the parent function. A is 1, h is 0. That's why there's nothing inside there. All right, so this would be the same thing as the absolute value of x. Now notice what happens when the a gets bigger. See how the graph gets skinnier? It's getting stretched. And if I go down below 1, you'll notice how now it's going to get fatter, wider. That's a compression. Now what I'm going to do is I'm going to change the h. Now I'm going to make h positive, so that means it's going to move to the right. However, you'll notice inside the function it's going to look like x minus 5 because there's a negative sign in front of it. So when I'm looking at the function, when it says x minus 5, it really moved to the right. And if I move it this way, so I put a negative number in there, well, now it's going to be x minus a -2, which is the same thing as x plus 2. When it says plus 2, it actually moved to the left. It's always going to be the opposite of what you see. And then the k, well, that's going to make the graph go up and down. If it's positive, it's going to go up. And if it's negative, it's going to go down. So here now I've got k at -5. And then back to 0. There we go. All right, now the last thing I want to show you is I'm going to get rid of this stuff here. Is what's going to happen if I put a negative sign, if I multiply the whole function by -1. So I'm going to put negative and then absolute value of x. So again, I'm going to click the keyboard, get my absolute value, get the x. And you'll notice that what's happened is that the negative sign in front causes the graph to reflect over the x-axis. And if I put a 2 in there, it's going to make it skinny, but it's still going to reflect. The negative sign only makes it reflect. The 2 is going to make it stretch. And then if I put a +4, it's going to move to the left. And then at the end, if I put, let's see, put a -3, then the whole graph's going to shift down by 3. All right, so the Desmos is pretty awesome as far as doing the graphing, and you can use it to help you out answer some questions if you need it. All right, I appreciate your attention. I appreciate you watching and taking notes, and I really do hope it helped. Have a great day.